This is the 40th lecture in the FOA series on fiber optics. In this lecture, we're talking about distributed antenna systems, also called DAS, which are used to bring wireless cellular signals into areas where they don't normally penetrate. Subscribers are using more mobile devices which use more bandwidth, especially for data and video. That requirement for more bandwidth requires more spectrum, which means more frequencies, and that means more antennas. So more fiber bandwidth is needed for those cellular systems. Over the last 7 years, AT&T's data traffic on their cellular systems have increased 50,000%. That's 500 times since the introduction of the iPhone in 2007. But 70 to 80% of all cell phone connections originate inside a building. In order to provide coverage in areas that we call dead zones, where cellular signals don't penetrate, like inside large buildings or tunnels, or even on some campuses, or to expand the coverage for large gatherings, like a large number of people typical in convention centers, sports facilities, airports, and mass transit, we now use distributed antenna systems to provide that coverage. In many areas, especially large cities with large numbers of big buildings, buildings are required to have wireless service inside the building for emergency personnel, fire, police, and emergency medical technicians. This requires that building owners provide for proper cellular coverage throughout their buildings. Typical cell towers outdoors cover large areas, but small cells and distributed antenna systems cover much smaller areas, which means the antennas are lower power and serve fewer users. Serving fewer users means there's more bandwidth available for each user, which works much better for those users using data and video services over their mobile devices. There are two different types of DAS, passive and active. Passive DAS systems are simply repeaters for signals to and from an outside antenna. The electronics amplify the signals and connect to remote antennas over large, typically 12 to 25 millimeter coaxial cables. Besides the obvious noise problems with all analog systems, the coax cable runs are limited to about 100 meters, 330 feet, making this a difficult system to use in large buildings or structures. Passive systems have been used in small and medium-sized buildings up to 10,000 to maybe 200,000 square feet for years, but are being replaced by active digital systems. Modern DAS typically uses fiber backhaul to connect to all the wireless service providers, although it can still use outdoor antennas connected over coax. The service provider head-end converts the signals to digital and transmits optically over fiber to remote antenna units, which are in turn connected to small, low-powered antennas within the facility. The signals carried over fiber are digital, typically one of two protocols, CPRI or OBSAI. The fiber is generally single mode, and some systems even use wavelength division multiplexing to require fewer fibers in very large systems, and some of these systems can have hundreds of antennas spread out over relatively large areas. There are generally two types of DAS. What's called carrier-owned means that one system provider installs the system and the system only handles that carrier. Needless to say, that's fairly unusual these days. Most are neutral host systems, where one system handles multiple cellular carriers and sometimes even other systems, like Wi-Fi. In the business, you'll also see two acronyms used, which are pretty straightforward. IDAS for indoor and ODAS for outdoor. Cabling for DAS is very similar to premises cabling networks used for other systems. The architecture of DAS cabling is no different from an Ethernet LAN or standardized structured cabling. A DAS can share backbone cables and telecom rooms where power is available for the remote antenna units. In some cases, DAS can be monitored by the same network management software used for LANs. A DAS is also compatible with a cabling system used for passive optical LANs based on fiber-to-the-home technology. Passive optical LANs use GPON technology are becoming popular for enterprise LANs. These GPON OLANs use single-mode fiber, which is fully compatible with DAS systems. The two can share fiber backbones and co-locate remote antenna units and GPON splitters in typical telecom rooms. At the current time, there are no cabling standards for DAS. While TIA is working on one, it's only recently been started and is likely to take years to be completed. While standards bodies seem to want to cover every application with a standard, many applications like DAS don't lend themselves well to cookie-cutter standards. Every DAS application is different, and custom designs are needed for economic, efficient systems. There are a number of factors to consider in designing a DAS. Neutral host systems may have to accommodate 4 or more service providers, so entrance facilities must be designed to allow adequate entrance conduits and space for equipment. AT&T recommends approximately 3 by 10 meters space, that's 10 by 30 feet, for the entrance facility, and providing 200 amp service for the head-end electronics. Antennas generally are shared by service providers, so only one set of antennas and remote antenna units are required inside the building. They may be connected on 2 fibers for full duplex transmission, while other systems use wavelength division multiplexing, like fiber to the home, to connect on 1 fiber. Like any network and cabling installation, a site survey is performed prior to the final design. The objective of the survey is to characterize wireless signal propagation within the building and to investigate equipment space and cable routing issues. This building characterization is the basis for system design. Once you know where the head-end equipment will go and where antennas are needed, you can start designing the cable plant. Proper engineering and planning will minimize capital expenditures while ensuring that adequate coverage for each of the mobile service providers is available. A DAS may be installed indoors, like in a convention center or an airport, or outdoors, like a sports stadium, or a combination of both, like a college campus. The type of location will determine the type of cabling components and installation techniques necessary for that particular application. A modern DAS will use fiber, typically single mode, to connect the head end to the remote antenna units, and then use coax to the antennas. Installers need to be familiar with both fiber and coax installation and testing. Installation of cabling for DAS follows normal procedures for premises or outside plant cables. If fibers are available in the current cable plant, for example, the one installed for the LAN, one can simply patch in the equipment. If new cables are needed, follow the usual installation procedures. Field terminations, particularly on single mode, will typically use spliced-on pigtails or pre-polished splice connectors. If small fiber counts are needed, it's possible to use prefab assemblies where the installation is simple. But as with all prefabs, be careful to inspect and clean every connection. With short single-mode links, loss should not be a problem, but reflectance can cause transmission problems. For more information on distributed antenna systems and using fiber to support other types of wireless applications, go to the other videos on the FOA YouTube channel or the FOA online guide at the FOA website. We're the Fiber Optic Association, the international nonprofit professional society of fiber optics.